19 paper. Okay, the restricted answer in the 2019 paper, this is question 1. Sodium thiosulfate can be used to investigate the effect of reaction conditions on the rate of reaction. Sodium thiosulfate solution reacts with hydrochloric to form a precipitate of solid sulphur by placing the reaction mixture in a conical flask over a cross, recording the time taken for the cross to disappear. The effect of changing the reaction conditions can be investigated. Okay, and you've probably done this one. Okay, the equation for the reaction is given, balance the equation. That's quite a nice first question, to be honest. Right, so our sodiums are 2 on the left, 1 on the right, so I'm going to times that by 2, which means that I have 2 sodiums and 2 chlorides. I have 1 chloride over here, so I'm going to put a 2 in there, which means that I now have 2 hydrogens, which I already have on the other side. Let's check the rest. I've got 2 sulfurs going in, I have 2 sulfurs coming out, 3 oxygens going in, 2 on the sulfur dioxide, 1 on the water, and that's at balance. Okay. In one set of experiments, the effect of varying concentration of sodium thiosulfate was investigated. Complete the table to show the volumes of water that would be used to vary the concentration of sodium thiosulfate. I genuinely can't believe this is worth a mark, but you know, take it. Obviously your total volume has to remain the same, so volume is 50, and then you've just got your ones to put in. Okay. Calculate the time in seconds for the cross to disappear in experiment C. Okay, first one I think that is properly higher stuff. Right, so what we have here is the rate, okay, rate at 1 over t. I am looking for t, so t is 1 over rate. Plug it in, so I'm looking for 1 over 0.0285, and that will give me 35 seconds, or 35.1 or 30.5.09, depending on where you round to, but there you go. Oh no, miss C, sorry. No, we're here. The reaction can also be used to investigate the effect of changing temperature on the rate of reaction. Results from an experiment are shown in the graph below. You should recognise this kind of sweeping increase here. You expect that it doesn't take a vast amount of temperature to do a big bump in increase. Okay. Use the graph to determine the temperature rise in degrees C required to double the rate of the reaction. Okay, what you've got to do here is take 2 points and then calculate from there. Right, I took my relative rate as 0.02 and my relative rate at 0.04 because I thought that they were the easiest ones to read. Now, it is not easy to totally see this on the screen, okay? So you have to take a little bit of just trusting me in this one. Okay, so I'm going down and I'm going down. Okay, now where I read that, on my 0.02, I read that at 44. And my 0.04, I read that at 56. Okay, so that means that it took me 12 degrees C to increase the temperature. Went and checked the mark scheme and it said 12 degrees plus or minus 1. Okay, so what should happen at every single one, if you took 0.04 and 0.04 and 0.08, that should have given you the same number. If you took 0.12 and 0.06, should give you the same answer as well. It's just all to do with reading the graph cleanly. Okay. Collision theory states that for particles to react, they must collide with each other. State 2 conditions. Sorry, pen. 2 conditions necessary for collisions to result in the formation of products. Straight definition stuff. Actually quite nice. What have we got? They've got to collide. They have to collide with sufficient energy. And you can state that, if you wish to, as the activation energy. And they must collide in the correct orientation. Or with correct geometry, if you would rather put it that way. But that's it. That's the definition of collision theory. They must collide with sufficient energy and in the correct orientation. Done. C. Sodium thiosulfate also reacts with iron 3 nitrate. Potential energy diagram shows the change in potential energy during the reaction carried out without a catalyst. Draw an X in the potential energy diagram to show where the activated complex is. There we go. Right at the top of the curve. Worth a mark. Copper ions catalyze the reaction. Add a dotted line to show the change in potential energy with the catalyst. Okay, what you must do is to lower the activation energy but still maintain your delta H. Okay, so you still have to have this distance from it's not the neatest there, from your reactants to products. Okay, must remain the same. And then your activation energy has to be dropped. Okay, however you Wherever it is, as long as it's a dropped dotted line, it gets you the mark.